Hi everyone, Professor Clark back again for our next installment, of our rafter math. And today we will be going over our quiz. Let you look at those answers for a minute. As we go through it, you can check your answers against it. So everybody get out your quiz because number one, you can check your answers against it. Number two, I can't draw as much out on the board as I normally do. So I can't graphically show you some of the information I like to show you. You can follow along with it on your quiz, and I will show it to you on the quiz. All right, so we went through the quiz. Our common number 2. What do we need? We need our A, our B, our C, and our run. So those 4 things. So our run for our common number 2. Again, we can look at it width of our building right here. This is our common 2 here and our common 2 here on both sides. We should be able to see that shape. We got a square there. So we should be able to see in plan that our run is going to be half of that span. So half of my 9 foot 4. So half of 9 foot is 4 foot 6 inches. Half of 4 inches is 2 inches. So 4 foot 6 plus 2. We've got 4 foot 8 inches for our run. And we have to convert that to decimal feet so that we can do our calculations. So 4.67 feet. From there, we solve for the same pitch triangle we've solved for several times. Your next quiz will have a different pitch triangle. This first one, I just give you the same pitch triangle. We've got a 7/12 pitch. Tells us that in our specs. So we solve for that C once again. We've done it a bunch of times. C squared equals 7 squared plus 12 squared. C squared equals 49 plus 144. C squared equals the square root of 193, or C does, I should say. So C equals 13.89 inches per foot. All right, so 13.89 inches per foot. And very important to point out here. As I look at my rafters, I can start to understand something. That means that this common that I just solved for, my C is going to be 13.89 inches per foot. Is that going to be true for this common? Yes, it is. Is it going to be true for these jacks? Yes, it is. Is it going to be true for these jacks? Yes, it is. The point is that I know that C is going to stay the same because I'm hitting my top plate with all of those rafters at 90 degrees. So I can make my math much easier by understanding that, because now I know that I never have to solve for that again. Anytime a rafter hits my top plate at 90 degrees, for this roof system, for this 7/12 pitch system, I know that my C is going to be 13.89. So I don't ever have to solve for it again. I can just plug it in now. I can ask myself, all right, is that rafter hitting at 90 degrees? And if so, I know what my C is going to be. Once we solve one of these rafters for my rafter hitting at 45 degrees, I'll be able to say the same thing for that C. But let's go ahead and walk through and solve for our A and our B. Here I know my formulas never change. A equals C times run, and B equals C times overhang in feet. So my 13.89 inches per foot times my 4.67 feet. I do that math and I get 64.866 inches. And then I divide by 12, multiply by 12, multiply by 16, and I find that I have 5 foot 4 and 7/8 of an inch. So 5 foot 4 and 7/8 inches. All right. Likewise, my B is my C times my overhang in feet, so 13.89 inches per foot. Again, we've seen this several times now, times 18 inches divided by 12. 1.5 feet. So that equals 20.835 inches, which is going to equal 1 foot 8 and 13/16, and that is going to be my B. All right. So again, we see that now that I've solved for that C at 90 degrees, I don't ever have to solve for it again. What else do we see? We should start seeing. Okay, when I look at that common number 2, I can see that that B dimension, that tail, is the same as this B dimension, or that tail for that common number 1. How about again with my jacks? Yes, I can graphically see that all of those lengths are the same. So now I realize that I don't ever have to solve for this again either, as long as my raptor is hitting my top plate at 90 degrees. So I can fill in my A and my B dimensions for my common number 2, and I can also fill them in for my number D, my jack, or letter D, my jack. I can see that my B dimension is going to be 1 foot 8 3/16 for both of those. Okay, and likewise again when we solve for our hip, okay, I'll talk about that as we go through that. Okay, all right, so next we solve for our hip number 1. Okay, so hip number 1, I need my A, I need my B, I need my C, and I need my run. Okay, first our run. Okay, my hip number 1, that's my big hip on my big shape here. Okay, again, my span is 16 feet. So I know half of that, I can see it in my commons, half of that is going to be my run. And again, we said that's true with my hips and valleys too. Okay, so 8 feet, and that's true because we know that our C changes to a unit run of 16.97 inches. Okay, and that's what makes my raptor longer. So now C squared equals 7 squared plus 16.97 squared. So C squared equals 49 plus 287.981. So C equals a square root of 336.981. Okay, which equals 18.36 inches per foot. Okay, 18.36 inches per foot. Okay, and again, what does that tell us? That tells us, all right, what do I see here? I see a triangle. I see a 45-degree triangle in plan. And I see this one, same thing, same 45-degree triangle, same 45-degree triangle, same 45-degree triangle. Down here also, a 45-degree triangle, a 45-degree triangle. Here also, if I ran a straight line across there, I've got a triangle right there. I've got a triangle right there. Same thing with my valley. I've got 2 big triangles right here, okay? I'd have a triangle right there. And I know what? I know that that's a 45-degree triangle. Why? Because it's bisecting that 90-degree angle right here. I have 90. I can see it written right out with jack number 1. I've got a 90-degree angle right there. Okay, so that has to be 45 degrees at my top plate. Okay, so again, what are we saying? Geometrically, what are we talking about? We're talking about that in plan, okay, that's different when we're talking about pitch, or we're talking about in elevation, okay, but in plan, I'm dealing with squares and 45-degree triangles. Very simple shapes to deal with. Okay, and 99.99% of the time in construction, that's what we're going to find. If it were offset, I would have to use my trigonometry and go with SOHCAHTOA, but I don't. Okay, it's most of the time a 90-degree angle, unless some goofy architect designs something really odd. And if that were the case, I could solve for that too. Okay, but because I know my trigonometry. But most of the time, I don't have to. So that really simplifies the understanding of the math in my construction. Okay, most of the time I'm dealing with a square or a rectangle, which is just an elongated square, and a triangle. In plan, that's the case. Okay, in elevation, we're dealing with a different triangle, and that triangle is defined by my pitch. Okay, so hopefully everybody's starting to understand that from a geometric standpoint. Okay, so again, the point is that I never have to solve for this again. I can say my C at 45 degrees is always going to be 8.36 inches per foot for this 712 pitch roof. Okay, hopefully that makes sense to everybody. So now I can simply say, all right, if I'm talking about a jack, I know my C is going to be 13.89. If I'm talking about a common, I know my C is going to be 13.89. If I'm talking about a hip, I know my C is going to be 18.36. If I'm talking about a valley, I know my C is going to be 18.36. And it doesn't matter if it's that hip or that valley or that valley or that hip or that hip or that hip or that hip. Okay, does not matter. Anything that's hitting my top plate at 45 degrees, my C is going to be 18.36. Anything that's hitting my top plate at 90 degrees, my C is going to be 13.89. And again, that's the geometry. Okay, now we're using our algebra to solve for our geometry. But the geometry defines the shapes for us. Okay, and very simple shapes. All right, so from there, I apply my two formulas. A equals C times run, and B equals C times overhang and feet. That will never ever change, no matter what Raptor I'm talking about. So my A is 18.36 inches per foot times 8 foot. Okay, my feet cancel. I work that through. And I get 146.88 inches, which works out to 5'4" and 7/8 of an inch. 5'4" and 7/8 of an inch. Now my B, 18.36 inches per foot times my overhang, 1.5 feet. Okay, my overhang was given to me in inches. I divided by 12, got 1.5 feet. My feet cancel, and I get 27.54 inches, which works out to 2 foot 3 and 9/16. So 2 foot 3 and 9/16. And again, I go back to my chart and I see that applies to both that hip and that valley. Okay, so again, understanding everything from a geometry standpoint and then using my algebra to solve for that geometry. Once I've done that, it makes it much easier. I don't ever have to solve for this C. I don't ever have to solve for this C. I don't ever have to solve for this B if I'm hitting my top plate at 45 degrees, and I don't ever have to solve for my other B, okay, for my common, if I'm hitting the top plate at 45 degrees, okay? Okay, hopefully everybody understands that. All right, so you'll see now it makes it much easier to walk through and solve for all of my different rafters. Because now I go to valley number 1, or valley number 2, and what do I see? I need my A, I need my B, I need my C, and I need my run. All right, well, what have we already solved for? I say valley number 2 is hitting the top plate at what? 45 degrees. So my C is going to be 18.36 inches per foot. Don't have to solve for it again. Much easier. Okay? I also see in plan that my valley's tail is exactly the same length as my hip tail. I've already solved for that. Don't have to solve for it again. 2 foot 3 and 9/16. Okay? So it makes it much easier. All I have to solve for is A equals C times run. All right, well, I have to determine my run. We're looking at valley number 2, which is the same length as hip number 2. Okay? This valley number 1 goes all the way to the peak. This valley number 2 dies into that valley. Well, I should be able to see that shape right there. That's two 45-degree triangles, which are shaped exactly as same as this 45-degree triangle. So my run is right there, half that span. Have we already solved for that? Yes, we have. 4.67 feet. Okay? So easy peasy. Now all I have to do is plug my numbers in. Equals 18.36 inches per foot times my 4.67 feet. Okay, cancel, cancel. And I get 85.741 inches, which works out to 7 foot 1 3/4 of an inch. Okay, and everything else has already been solved for. So all I had to do is identify my run and then plug my numbers into my formula, and I get my 7 foot 1 3/4 of an inch. All right, jack number 4. A, B, C, and run. Okay, what do I have? What do I already know? Okay, the jack number 4, okay, it's this guy, right? 1, 2, 3, 4, that guy right there. Okay, jack number 4. What do I know? I know it's hitting my top plate at 90 degrees. So I know my C is going to be 13.89 inches per foot. I know it's hitting my top plate at 90 degrees. So my B is going to be the same as every other common. So my B is going to be my 1 foot 8 and 13/16. Again, we've already solved for that. Easy peasy. All right, so what about my run? Okay, my run, again, I have to understand it geometrically. Okay, so taking just our big shape, just the portion of the building that we're concerned with at this point, our big rectangle. Okay, I know my span is 16 feet. The width of my building is 16 feet. Okay, we don't have to worry about this little shape right here because we're dealing with this big shape. Okay, and again, understanding everything geometrically that we need to understand. I see that I have a hip here, a common here, and a common here, and a common here. Okay, and then I have 5. I have 1, 2, 3, 4, 5 jacks. 1, 2, 3, 4, 5 jacks. And I know my drawings leave a little bit to be desired. Okay, but hopefully you get the point. And again, you can look on your quiz and see it better. Okay, but what do I see here? I've got jack 1, jack 2, jack 3, jack 4, jack 5, and then I've got a common. I've got jack 1, jack 2, jack 3, jack 4, jack 5, and then I've got a common. Okay, again, what are we seeing here? We're seeing these shapes. Okay, I've got a little square right there. I've got another little square right here. Got a little bit bigger square here. Got a little bit bigger square here. Okay, and all these tails are exactly the same. And jack 1 is the same as this jack 1. Jack 2 is the same as this jack 2. Jack 3 is the same as this jack 3, and on and on. Okay, so we see that my jacks come in pairs. All right, well, if I'm looking at my common, my horizontal run, okay, or half my span, is going to be from there to there. Okay, again, 16 feet, half of that is 8 feet. Okay, same thing here. 16 feet, half of that is 8 feet. I should be able to see that geometrically. Okay, well, so that means from here to here is my run, and from here to here is the same run. From here to here is the run for this jack. From here to here is the same run. From here to here is the run for this jack. From here to here is the same run. From here to here is a run for that jack, which is the one we want to know. And then from here to here is the same run, which is the same as the other jack. Okay, well, what gives me this information right here? Okay, well, do I know what this dimension is? And do I know what this dimension is? Yes, I do. It's what? It's 24 inches on center. It is my on-center spacing. Okay, so we see it right there. I've got an 18-inch overhang and I'm 24 inches on center. Okay, and I know because this is a 45-degree triangle that that leg has to be what? The same as that leg. This leg has to be the same as that leg. Then I can go to the next one and I can create another box. So this leg has to be the same as that leg. This leg has to be the same as that leg. And on, all the way across my jacks. That leg has to be the same as that leg. Well, what is that dimension? It's 16 inches. It's 16 inches. What would the next dimension be? 32 inches. Next dimension, 48 inches. Okay, which jack is ours? It's 64. So what are we saying? We're saying the jack 4, yes it is. Okay, so jack 4 is 24 inches times 4. Okay, so, or better way to say it, 2 feet. Oops, I'm sorry. 16 inches, not 24 inches. I said it right there. I said it wrong here. It's 16 inches on center. Okay, I'm confusing myself just a little bit there. Okay, so what are we saying? 16, 32, 48. I did it there, right there. So 16 inches times 4, okay, is what we want. So I'd have 16, 32, 48, and then what? 48 plus 16, or I could just simply say 16 times 4. I actually think I have it written down there. Is 64 inches. Okay, what do we know? We have to be in feet, so 12 inches per foot. Okay, it cancels and I get what? I get 4.33 feet. Okay, that is my run. Okay, and again, and we can see that that is based on our 5.33 feet. Sorry, 64 divided by 12, 5.33 feet. And I'm able to check that on my computer, or my calculator. Yep, 5.33 feet. Okay, and again, what's important there is that it's based on our on-center spacing. If it were 24 inches, that would be 2 foot, because this leg would be 2 foot. That would be 48, because this leg would be 48. Okay, so whatever spacing I've got there tells me what my run is going to be. Okay, hopefully everybody followed that. So now I know my run is going to be 5.33 feet for jack number 4. Okay, jack number 1 would be 16 inches. Jack number 2 would be 32 inches. Jack number 3 would be 48 inches. Okay, and then I would divide that by 12 inches per foot, and that would tell me my run. Okay, all right. So my jack number 4, A, B, C, and run. Okay, we already determined that our C is my 13.89 because I'm hitting my top plate at 90 degrees. We already determined that my B is 1 foot 8 and 13/16 because I'm hitting my top plate at 90 degrees. And we just determined that our run is 5.33 feet. Okay, so the final rule that we've been talking about all these weeks is run is always half my span, except in the case of jacks, and then that they're based on my on-center spacing. Whatever my on-center spacing is, 16 by 16 by 16, 32 by 32 by 32 by 32, 48 by 48 by 48 by 48, 64 by 64 by 64 by 64, 64 divided by 12 is 5.33. Okay? All right, hopefully everybody got that. So again, now all I have to do is A equals C times run, which equals my 13.89 inches per foot times my 5.33 feet. My feet are going to cancel, and I am going to get 74.034 inches, which works out to 6 foot 2 and 1/16 inches. Okay, so 6 foot 2 and 1/16. Okay, so again, my math gets easier and easier because I understand the geometry. I understand the shapes that I'm dealing with. And that's a very, very important concept to understand, because that's what we do in construction with absolutely everything. Okay, we break our building up into shapes so that we can control that shape from every standpoint, whether it be to do some type of a quantity takeoff, okay, whether it be to solve the actual length of a rafter, whether it be to determine how we're going to handle that shape from a scheduling standpoint, from an estimating standpoint. Okay, basically that's what the two things that we're most concerned with in construction is a function of cost, which is my estimate, and a function of time, which is my schedule. From there, we have to resource it. How many people can I put in that space? Right now is a very good example of that. When construction opens up, okay, because of this COVID-19 response, when construction opens up finally, we're going to have very specific regulations that we're going to have to deal with. So now I have to understand that shape from an area standpoint. How many people can I put in there and still keep my social distancing in place? Because that's what's going to happen. 100% for sure, that's what's going to happen. Okay, so as a project manager, I need to start thinking about that. What's that going to mean to my job site? Okay, and again, what it comes down to is the shapes that I deal with. Okay, I have to understand everything from a geometric standpoint first, and then I can apply it. I can apply my algebra, I can apply my resourcing, I can apply my costs, whatever the case may be. Okay, so hopefully everybody understands that concept. Very, very important concept to understand. The first thing I have to understand is the geometry of my building. I have to understand my shapes, and I have to understand them thoroughly. Okay, I have to completely understand them. But again, we see that that's fairly easy once we realize that almost all of those shapes are squares and triangles, and those triangles are 45-degree triangles, which is a very easy triangle to deal with. Okay, every once in a while we throw in a radius, a circle, just to keep things interesting. Okay, but for the most part, especially concerning our buildings, okay, we're talking about squares and triangles. Okay, very easy shapes to deal with from every standpoint, once we know that. All right, so again, moving forward, what we're going to do is I will send you an email and I'll attach another quiz to it. Okay, in order to get the semester done, I'm probably going to give you 2 more quizzes. Okay, maybe 1 more assignment attached to that. I haven't come up with that yet. And then we're going to do, to repeat myself, then we're going to do test number 2, which is all the math that we've dealt with in the second half of the semester, our stair math and our rafter math. Okay, and there's some other stuff on there too I'll review for the test in one of the next couple of videos. Okay, but anyways, my point is that's going to be our final exam. Okay, obviously we're not going to be able to have the hands-on final exam. Okay, but as long as you understand the math, that's what's most important. Okay, and as long as you understand that math from both a geometric standpoint, okay, again, I can't repeat myself too much on that. As long as you understand the math from a shape standpoint, from a geometric standpoint, from there you can solve for whatever you need to solve for, using your algebra, using your trigonometry, okay, using the basic concepts that we use in construction. Okay, from a building standpoint, I usually use algebra. From a surveying or site standpoint, I use algebra and trig. Okay, so you guys are learning that as you move forward. Okay, so again, hopefully everybody gets the concepts at this point. And again, we're not talking about carpentry. We're using carpentry as the example to teach the bigger concepts that we need to be concerned with to manage a project. Okay, to be a superintendent, to be a project manager. Your guys' case, to be a PE. Okay, to be an intern for the next couple of years, and then to be a PE first, and then move one way or the other, field or office. Okay, but we all need the same math. I don't care if you're a superintendent, project manager, pre-construction, which is estimator, scheduler. Okay, doesn't matter. We all have to have the ability to understand the same math so that we can apply it in different ways, as a function of cost or as a function of time. Okay, and again, that's really why we're doing this. Okay, it's not just so that you can cut a rafter. That helps you understand it, and it breaks my heart that you guys are missing that. But what's most important is that we understand the math from a geometric standpoint and then from an algebraic standpoint or otherwise, so that we can apply the concepts that we need to apply. All right. Hopefully that makes sense to everybody. Hopefully everybody's doing well. Okay. Hopefully everybody's keeping safe. You guys are young and strong. You don't have to worry about this thing too much. Okay. So just do what we need to do, and we'll get through this. Hopefully you guys will be able to experience your internships as much as possible this summer. I know there's going to be some issues, but we'll get through this, and we'll pick up speed after we're through it. Okay, so everybody stay strong. Just keep doing your schoolwork and do the best you can. Get as much out of it as you can. Okay, as far as that's concerned, you should be focusing on it even more right now. Okay, it's better that you can get that hands-on experience up north. Okay, you can experience the lab environment, but you still need the knowledge. So you should be really paying attention and noodling on these concepts so that you get that knowledge moving forward into the program. Okay, and that's why I'm probably going to send you a couple more quizzes so that you can practice the math even more. For those of you that are getting it no problem, that'll just be a little bit of added work, but making sure that everybody gets these concepts to the best degree that we can do. So, all right. So again, you're going to have another quiz. Next video, we'll be going over that quiz and talking these concepts through a little bit more. And then from there, I'll decide exactly. We'll do another thing or two, and then we'll finally do the last test and the final exam. Okay? All right. Everybody have a good night. Bye.